All right. Good morning once again, everyone. Good morning, students. All right. So today is the start of the new unit. Okay. And this one will be this topic about atmosphere is divided into two units. Okay. We have atmosphere 1 and then atmosphere 2. So today we'll be starting with atmosphere 1. Okay. So that's atmosphere 1, and then after this, maybe after the midterm, we'll be uh, focusing on atmosphere number 2 with the different lessons and topics. Okay, so for now, we'll have this one, and then I will introduce to you about this lesson. So the first one is atmosphere. Okay, atmosphere. Now, what is atmosphere, teacher? Right, so we're going to define first what does it mean by atmosphere, right? So class, when I say atmosphere, yeah, here atmosphere. Where is it? Hello, Chertam? Where is Chertam? Can you help me read this one, please? Hi, Chertam. Atmosphere is
Atmosphere is the air around us, starting from the ground until reaching the level of the sky, or the air that covers all planet Earth.
yes, thank you, Chertam. Very good. Okay, so that's atmosphere. Okay, so when I say atmosphere, it is the air, right? The air around us. Okay, so the air that we breathe composes the atmosphere. Okay, so the air around us is part of the atmosphere. It starts from the ground. Okay, it starts from the ground until up above. Okay, up above the sky, or the air that covers our planet Earth. Okay, all of the air that covers the planet Earth is atmosphere, or at least part of the atmosphere. Okay, you understand that? Okay, so all of the air that covers the earth is atmosphere. Okay, now it is a mixture of, when I say atmosphere, it is a mixture of combined, okay, combination of gas. It's a mixture of gas, number one. Number two, dust, a combination of dust. What else? Water vapor, combination of water vapor, clouds, and precipitation. Okay, clouds and precipitation. Next, absorb heat and energy from the sun. Okay, so all of this, okay, all of this mixture, okay, is what we call atmosphere, right? This is what we call atmosphere. And this is air. Okay, this is air that we breathe, right? So that's clear, right? Now another question is, I have another question. Why is the atmosphere important? Why do you think is the atmosphere important to us, especially to us, the people or human? Why is the atmosphere important? First, weather exists because of the atmosphere. Okay, so the weather that we have right now, it exists because of our atmosphere. Let's say, for example, today is cold. Let's say today is, I don't know what's the temperature today. What's degrees Celsius? I don't have a record. Okay, but the temperature that we have today is because of atmosphere. Okay. Next one, it makes the earth suitable for living things. Okay, because of the atmosphere, the earth, all living things can live on earth, like human, people, animals, and plants. Okay, that is possible because of the atmosphere. Next, the atmosphere is the layer of gas. It's the layer of gas that surrounds the planet. Just like on the definition. Another one, the atmosphere traps energy from the sun. Okay, The atmosphere traps energy from the sun and keeps the Earth's surface warm enough for water to exist as a liquid. Okay, because it traps the energy from the sun and from escaping from the surface of the planet. And because of that, the Earth's surface is warm enough, okay, so that we have water, okay, water to exist as a liquid, right? In other planets, they don't have that, okay, they don't have that. What else? Another importance is that it protects the Earth from radiation, okay? It protects the Earth from radiation. In order for not all of the radiation from the sun reach the planet, we have the atmosphere, right? So it protects us, it protects the planet. Okay, so that's the importance of atmosphere. That's why the atmosphere is very, very important. Next, what are the components of, I have said that it is made up of the air, okay? So what's the components of the air, okay? So the air, it is a substance necessary for all living things, okay? The air is a substance necessary for all living things. So as you can see here, we have here nitrogen, 78%, oxygen, we have 20.9%. Can you see that? Then this one, argon, that's about 0.93%. And then the orange one in here, we have carbon dioxide. And then the purple one, other gases. Okay, when I say other gases, some other elements. Okay. Question: which component of air has the most quantity? Hi, Ing. Can you turn your mic on, please, Ing? Which of this here, which of this has the most quantity, the largest quantity? Which part of the air, which component of the air? Hi, Ing. Is Ing still here?
Yes.
Hi, Ing. Which one of this has the highest quantity?
Nitrogen.
Nitrogen. Okay, that is very good. Correct. Okay. How many percent, Ing? Nitrogen is that
28.
sorry, okay, that's 78. Okay, 7. Okay, sorry, this is 7, 8 in. Okay, that's 7-8%. Okay, maybe it's small in your laptop or in your phone. Okay, so it's nitrogen. I will repeat, it's 78. Okay, so the air is composed of most of this with the largest or highest quantity is nitrogen. Okay, nitrogen, which is about 78%. Okay, so the air that we breathe, the air around us, it's composed of 70% nitrogen. Okay, thank you so much, Ing. Next one, Pancake. Hello, Pancake. Can you turn your mic on, please? Which component of air has the second? Okay, first nitrogen. How about the second? Hello, Pancake. Are you still here? Pancake? Mio is here now. Pancake. Hello.
Oxygen.
All right. How many percent, Pancake? How many percent?
20.9.
20.9. That is correct. Very good, Pancake. So oxygen has the second most quantity. Okay, second most quantity. That's oxygen. Okay, so oxygen. Living things like us, human, people, and then animals. Okay, we are breathing oxygen. Okay, so that's why it's very important. Oxygen is very important to us human being. Okay, that's the second highest. Now, oxygen is the second highest. Now, next question, number 3. if the quantity of these components changes, does this affects the Earth? Does this affect us? Let's say if, for example, we will only have, let's say, for example, we will only have 5% oxygen. Oxygen will only be 5%. And then carbon dioxide, let's say it will become 15%. Okay, does it affect us? Let's say, for example, if all of this component changes, say oxygen becomes only 5% and then carbon dioxide becomes 15%, it will affect us, right? So it will affect us. Yes. The answer for number 3 is yes. Okay, it will affect us. For example, right now, the carbon dioxide is not yet 15%, but it is increasing. Okay, it is increasing, and then the effect is we are now experiencing what we call climate change. Okay, climate change because of the increasing amount of carbon dioxide and other gases harmful, okay, harmful to the atmosphere, harmful to the environment. Okay, so it means that slowly this percentage is now changing. Okay, this percentage is now changing slowly. Okay, and it is, that's why it is affecting the Earth. Next, are the components of air in each area similar or different? Are the components of air in each area similar or different? For example, are the components in a forest same with the components of air in the city? Do you think? You can answer in the chat box. Do you think are the components of air in the forest the same with the components of air in the city? For example, in the forest, the same percentage, and in the city, same percentage. Do you think? Do you think it is the same? Like in the city and in the forest? We have here, no. Okay, Yok said no. Why do you think, Yok? Can you turn your mic on, Yok? Why do you think no? Hi, Yok. Can you turn your mic on? What do you think is more, what component do you think is more in the city and then more in the forest? Yok. Do you think in the city there are more, what component? Right? For example, you will think that in the city, for example, you will think that there are more carbon dioxide. Jamaica, there are more carbon dioxide in the city. For example, in Bangkok, okay, in Bangkok, there are more carbon dioxide compared to in the forest. Okay, in the forest, of course, there are more oxygen because there are more trees that would release oxygen. Okay, so it's not the same. Okay, so the components in different areas are not the same. Okay, so let's say, for example, in the forest, of course, there are more oxygen, and in the city, there are more percentage of carbon dioxide. Okay, so that is, Yok is correct. The answer here is no. Why? Because it's industrialized. In the city, there are more cars, there are more factories, okay, and they are releasing carbon dioxide. And in the forest, there are more plants, there are more trees, and they are releasing oxygen, right? Okay, so that's why they are not the same. They're always not the same. Okay, so that's clear for you, with you, class? So this is about atmosphere, and these are the different components of the air, okay, the air which makes up the atmosphere, right? So the next one here will be proceeding with the layers, okay, the layers of the atmosphere. Okay, so we have here from this what we're talking about. That's since this is the Earth, for example. This is the Earth. And then the atmosphere is from the surface of the Earth going up. Okay, going up is part of these are all part of the atmosphere. Okay, from the surface going up. Okay, so we have here the height from the surface going up is what we call altitude. Okay, altitude right here, altitude. Okay, altitude. This is the height of the atmosphere. Okay, from down going up. That's what we call altitude. So that's from, let's say, for example, from the surface, we have 6 miles, 16 miles, 31 miles, 53 miles, 373 miles going up. Okay, in miles. Or we have here on the other side, can you see this one? We have from the surface going to 10 kilometers, 25 kilometers, 50 kilometers, 85, 600 kilometers going up. Okay, so that's the surface. And you can see here, the first layer is what we call the troposphere. Okay, so the first layer here is the troposphere. Okay, and then the second layer here, the second layer is the stratosphere. The stratosphere, but under the stratosphere, there is a sub-layer, what we call ozone layer. Okay, so ozone layer is a part of stratosphere. Okay, and then we have the third one, which is at the middle, is what we call the mesosphere. Okay, mesosphere. And then the fourth one, we have here the thermosphere. And then the last layer, the uppermost layer of the atmosphere, is what we call exosphere. Okay, exosphere. Teacher, why are the layers divided into this? Okay, so the layers, the atmosphere of the Earth is divided into different layers from tropos, stratosphere, mesosphere, thermosphere, exosphere. They're divided into these different layers because of the change in air temperature. Okay, air temperature. In other words, the temperature in this different layer, okay, in the different layer of the atmosphere changes. Okay, so the temperature is not the same, right? The temperature is not the same. Okay, so we're going to study this one by one, and then we're going to identify the characteristics of each layer. Okay, the characteristics of each layer. And then we're going to start with the first one, troposphere. Okay, because if you will notice here, we have here, you can see the clouds on this layer. We have the airplane, okay, uppermost layer here. Then we have this one, meteorites. Then this one, do you know this one? And then satellite here in this layer, of course. Okay, so we're going to study that one by one, starting with troposphere. Okay, troposphere. So again, troposphere, this is the bottom layer. Okay, the bottom layer from the Earth's surface to about 12 kilometers above. Okay, so from the ground going up, up to about 12 kilometers. Okay, altitude, 12 kilometers altitude, or from 0 to 7.5 miles, okay, on the average. So that's the first layer, the bottom layer. Another, aside from it's the bottom layer, of course, we know that there is where we live. Okay, this is where we live. Okay, so the layer that in which we are now is what we call the troposphere. And then this is where the weather happens. Okay, this is where the weather happens. The clouds form in this layer, formation of the clouds. The air moves a lot here. Okay, so the clouds form and then the air moves a lot. And then that's why tropo here, tropo means turning or changing. Okay, that's where the name came from. Tropo means turning or changing. Turning or changing. What else? Okay, so it gets colder with increasing altitude. Okay, as you go higher, it gets cold. Okay, it gets cold as you go higher. Okay, to about -55. Okay, it says here, think about how it gets colder on a mountain. If you go high on a mountain, you'll feel cold. Okay, it's something like that, similar. Okay, as you go higher in the atmosphere, it gets colder. Okay, up to the tropopause. Okay, tropopause. What is this? What is tropopause, teacher? It's the boundary between tropopause and another layer. Okay, so the boundary, like we'll draw here, like this is the troposphere, troposphere, and then the next layer is stratosphere, stratosphere here. So the boundary between them, this one is called tropopause. Okay, tropopause. That's the boundary. Okay, understand? Do you have question about troposphere? This is where we live. Next, another one. Most of the atmosphere's mass is found here. Okay, most of the atmosphere's mass is found here. In other words, most of the component of the air, like nitrogen, oxygen, carbon dioxide, most percentage are found in the troposphere. Okay, most of them are found in the troposphere. This is the densest layer. It has the highest density, okay, because gravitational pull is stronger here, okay. The pull going through the center of the earth, the pull going through the center of the earth is very strong in this layer. Why, teacher? Because again, this is the closest layer to the atmosphere. This is the bottom layer, okay. You understand that? That's why the gravity is very strong in this part. Okay, good morning. I now have 10 students. Do not leave until we finish, okay? So I can check your attendance later. Next, jet stream is in upper troposphere and lower stratosphere. What do we mean by that? Means that airplanes, the airplanes fly on the upper troposphere but lower stratosphere, okay, higher, but they were saying that usually, okay, normally airplanes, they fly at the next layer, stratosphere, okay, but sometimes they were saying that they are flying on the upper, okay, upper part of the troposphere, okay, the upper part of the troposphere. Okay, but normally airplanes fly on the second layer, which is the stratosphere. Okay, another one here, the troposphere exhibit what we call greenhouse effect. Okay, greenhouse. Can I write here? Greenhouse effect. G-R-E-E-N, greenhouse. Sorry about this one. Greenhouse effect. Okay, greenhouse. It's a greenhouse effect. E-F-F-E-C-T. Okay, greenhouse effect. Okay, what is that, teacher? When you say greenhouse effect, this is the warming, okay, warming of the Earth's surface, warming of the Earth's surface, specifically the troposphere, okay, the warming of the troposphere, okay, because of the presence of water vapor. Because of water vapor, carbon dioxide, methane, and other gases in the air. Okay, so in this case, in greenhouse effect, it traps the sun's radiation. Okay, let's say the radiation get inside the troposphere, and then the radiation can no longer get out. Okay, can no longer get out. They are trapped inside. So what happened is it makes the earth warm. Okay, it makes the earth warm. Okay, that's why we can live here. But because if the presence of carbon dioxide increases, okay, the presence of carbon dioxide increases, there will be more heat that will be trapped inside. Again, we will have global warming. Okay, climate change, global warming. Okay, so if that will continue to increase, climate change will continue also. Okay, so that is greenhouse effect. Okay, you understand the first one, the first layer? I will repeat. Layer number one, this is the bottom layer. Bottom layer. If you go higher, it gets cold. Okay, it gets cold. What else? Most of the weather happens here, like the clouds are formed in here. The air moves a lot in here, and then this is the layer in which we live. Okay, this is the layer in which we live. That's the troposphere. Okay, next slide is, what time is it now? Let me check. Okay, we still have 5 minutes. Okay, we'll proceed with layer number 2. Okay, number 2 is stratosphere. Okay, that's the second layer. So here the first layer is troposphere. Number 2 is stratosphere. Okay, stratosphere. Sorry, it's 9:20. 15 minutes more. We still have a lot of time. Okay, so stratosphere is the second layer. This is above the troposphere. Okay, above the troposphere. Now, you can see where it begins because large cumulonimbus storm clouds reach into and stop at the lower stratosphere. Okay, so if you're going to look at this one, the clouds above this one is the beginning of the troposphere. Okay, it's the beginning of the troposphere. It extends up to 50 kilometers above. Okay, 50 kilometers above. Compared to the troposphere, it has less air pressure. Okay, troposphere, high air pressure, but in here, stratosphere, it's less air pressure here. Okay, because there's less mass, less density, and then less gravitational force. Okay, all less. Okay, when you go higher, it's less. Okay, because it means that you can find less oxygen, less nitrogen, less carbon dioxide compared to the first layer. Okay, stratosphere. Okay, so it's less compared to the first layer. Okay, another one. When we say strato, the word strato here, it means spreading out. Okay, strato here, it means spreading out, or air does not move a lot here. Okay, the air does not move a lot compared to troposphere, where the air moves a lot. In here, the stratosphere, the air does not move a lot. Okay, that's the difference. The air does not move a lot. And then As I've told you here, in stratosphere, lower stratosphere, there is what we call ozone layer. Okay, ozone layer. This is the ozone. Okay, ozone is formed in this layer. Okay, ozone is formed in this layer. This one is the chemical formula, ozone. What does it do? The ozone layer absorbs, it absorbs most ultraviolet radiation from the sun. Okay, the ozone layer protects us from the harmful ultraviolet radiation from the sun. Okay, so that's ozone layer. The question, is it good or bad? Is it good or bad? Depends. Okay, it depends on the kind of the ozone layer. If it is the layer found on the stratosphere, then it's good. Okay, it's good because it protects the earth, okay, from the harmful radiation. Okay, but if it is the ozone found on the troposphere, then it's not good. Okay, because it's harmful. Okay, it's pollutant. Next. Right, so in this layer, as you go higher, okay, as you go higher, the temperature increases, okay? Do you remember first layer? The temperature, it becomes colder. It gets colder as you go higher, right? As you go higher. But in here, stratosphere, as you go higher, the temperature increases. What do you mean by that? It means that it becomes hot. Okay, hotter as you go higher. Okay, in the stratosphere because of ozone. Okay, so because of the ozone layer, as you go higher, the temperature becomes hot. Okay, why, teacher? Why is that? The temperature becomes hot. Okay, as ozone molecule absorb ultraviolet, they get energized. Okay, they get the energies, and because of that, they move faster and produce a lot of heat. Okay, so that's why, because of the ozone, that is why as you go higher, the stratosphere, the temperature gets hotter. Okay, the temperature increases. Okay, you understand that? That's the second layer. The second layer. Next one, and then I will repeat, lowest part of the stratosphere, this is where the airplanes fly, okay? Lowest part, okay? Highest part of the troposphere, and then lowest part of the stratosphere, this is where the airplanes fly, okay? Stratosphere, lowest part. Okay, next, number 3 is what we call mesosphere. Okay, mesosphere, it extends from 50 to 90 kilometer. Okay, the third layer. Meso here, it means middle. Okay, middle, because this is the layer found at the middle. We have 5 layers, right? Troposphere, stratosphere, mesosphere, okay, at the middle, and 2 more higher. Okay, so mesosphere is the middle layer, okay. And then next, 99.9% of the mass on this layer is found below, okay, below the mesosphere, okay, lower, not high, okay. And then what else? There is not enough oxygen, okay, very thin, very less, okay. The percentage is very less, okay, percentage is very less, okay, very small amount. Another one, most meteoroids burn up here, okay, most meteoroids here burn up here. If you will see flying meteoroids, okay, that's burning on this layer, okay, mesosphere. You see that in the sky, okay, that's the mesosphere. The air is very thin, very thin, meaning very little amount of air. but still dense enough to slow down meteoroids due because of friction. Okay, that is mesosphere. There is not enough ozone layer, no ozone layer here to cause heating. Okay, so because there is no ozone layer, the temperature decreases again. Okay, as you go higher, it becomes colder. Okay, it becomes cold again. Why, teacher? Because there is no ozone layer. Okay, so actually, this is the coldest layer. Okay, this is the coldest layer of the atmosphere. The temperature could go down to 148 degrees Fahrenheit or negative 100 degrees Celsius at the mesopause. Okay, again, mesopause is what we call the boundary. Okay, so we have here troposphere, the boundary is tropopause. And then the boundary between stratopause and mesopause is stratosphere, and mesosphere is stratopause. Then boundary between thermosphere and mesosphere is mesopause. Okay, so if you go higher from the mesosphere going to the mesopause, the temperature is very, very cold at negative 100 degrees Celsius. Okay, again, why, teacher? Why very cold? Because there is no ozone layer in this area. So therefore, there will be no particles that can move. Okay, that's mesosphere. Number 3, layer number 3. Okay, next. The last one is thermosphere. Sorry, not the last one. Number 4. Number 4 is thermosphere. Next one. Thermosphere is above the mesosphere. Okay, it's above the mesosphere. Least dense. Okay, this is the least dense of all the layers because there are few molecules. Okay, the few molecules are far apart and moving fast because of radiation. Okay, very fast. What else? We have here some satellites are found in here. You can see satellites here orbiting around this layer of the atmosphere. And then the temperature can reach 2000 degrees Celsius. Okay, the temperature is very high, 2000 degrees Celsius, but would feel very cold. Okay, it's odd, right? Because the temperature is very high, but it could feel very cold. Okay, why is that, teacher? Because too few hot molecules to transfer heat. Okay, there are very few molecules, so they cannot transfer heat. Okay, so that is why, although the temperature is very high, but would feel very cold. Okay, so the temperature can vary here because of solar activity. Okay, in other words here, thermo here means heat. Okay, thermo means heat because the temperature could get as high as 2000 degrees Celsius. Okay, so the thermosphere, sometimes this is divided into 2 layers. Okay, thermosphere sometimes divided into 2 layers. We have the ionosphere and then the exosphere. Okay, ionosphere and then the exosphere. So what is ionosphere? Ions. When we say ions, this is the charge layer of the atmosphere. Okay, ionosphere is the lower part of the thermosphere. That AM radio waves, the bounce off these ions and way back to the earth. Okay, so we have radio waves from here bounce off going to the earth. Okay, back to the earth. Okay, this is where you get the signal of the transmission of the satellite, TV, communication signals. Okay, that is happening in here. Wait now, I'm going to charge my laptop. Sorry, forgot to charge the laptop. What else? Okay, another one here is this one. What do you call this one? This is, do you know this one? This is called the Aurora Borealis, or the northern lights. Okay, so this is very beautiful sky. Okay, we call this as the Aurora Borealis. Okay, so it happens on the ionosphere. Okay, it's glowing ions because of a lot of charged particles on this layer. Okay, and this is part of, again, this is part of the thermosphere. Okay, thermosphere. You can see Aurora, how do you read this? Aurora Borealis, or northern lights. Okay, you will observe that in countries like Finland, Iceland. Okay, and the last part, the last layer. Okay, so before we, last minute, the last part is the exosphere. Okay, the exosphere is the outermost part. Okay, the outermost layer of the atmosphere. Okay, exo means outer. Okay, exo means outer. Okay, and in here, this is where you can find the satellites orbiting. Okay, most of the satellites orbit in this layer. Okay, what else? Atoms and molecules escape into space. What else? TV and cell phone signals travel to satellite here and are bounced back. Okay, so TV and cell phone signals travel to satellites here and are bounced back to the Earth, right? So this is the outer space, the exosphere. Okay, you understand that? I will repeat. We have troposphere, stratosphere, mesosphere, okay, and then thermosphere, and then exo. Okay, so sometimes it's just thermosphere divided into ionosphere and then exosphere. Okay, so these are the 5 layers of the atmosphere. Do you have a question? You understand that? Do you have a question, class? Let me see who are here. I have 10 students. So I think it's time already. Okay, so let me check again who are here now. How about Xinjiang? Are you here, Xinjiang? Xinjiang. Xinjiang is here, okay. Right, Xinjiang present. How about Gawin? Is Gawin here? Gawin here, and then Plume. Plume.
Yes.
And then Miu. So sila the Miu. Well, how about Q, Fa, and Seaweed? Q, Fa, and Seaweed. Are you here? Q, Fa, and Seaweed absent today. Okay. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. Okay, so Q, Fa, and Seaweed absent today. Okay, so it's time already, everyone. Thank you for today. I will see you again tomorrow. Okay, bye-bye. See you tomorrow. We'll continue with that.
Thank you, teacher.
You're welcome. Thank you.